The aim of this problem is to find the power associated with the two voltage sources in this given circuit using node voltage method. The main steps in applying the node voltage method are shown here. So let's see how we can systematically apply these steps to solve the circuit. Looking at this circuit, we have two ideal independent voltage sources and 5 resistors. The first step is to identify essential nodes. Recall that an essential node is a point in a circuit where 3 or more circuit elements meet. This point here is a node because 2 circuit elements are joined together here, but it is not an essential node. This point is an essential node. 3 circuit elements are joining. This point is an essential node. 3 resistors are joining. This point is a node. Only 2 circuit elements are joining. And then this whole bottom conductor is an essential node because 4 circuit elements are joining here. Step 2 is select one of the essential nodes as a reference node. In this example, it is a good strategy to make this bottom conductor, which has the largest number of connections, as the reference node. Step 3 is apply Kirchhoff current law to the remaining nodes. So let's label these node voltages as V1 and V2. And then assume all branch currents are flowing away from the node. So we have 1, 2, 3 branch currents, and similarly 1, 2, 3 branch currents. Now we are ready to use Ohm's law and the circuit information to write the KCL equations. So looking at node 1 first, this branch current through the 8 ohm resistor is given by voltage at this side with respect to ground, which is V1, minus voltage at this side, which is 0. So this is V1 minus 0 over 8. This second branch current is voltage at this side minus voltage at this side divided by resistance. So this is V1 minus V2 over 6. Finally, this branch current is voltage at this side with respect to ground, which is V1, minus voltage here. Because we have a voltage source connected between this point and ground, so the voltage here is 40 volts with respect to ground. So this branch current can be written as V1 minus 40 over 2, and these are all branch currents leaving the node, and their sum is equal to 0 because here we don't have any current entering the node. Similarly, applying Kirchhoff current law at the second node, this branch current will be voltage at this side minus voltage at this side divided by resistance. So V2 minus V1 over 6. This branch current will be V2 minus 0 over 6. And then this last branch current will be voltage at this side with respect to ground, which is V2. The voltage here with respect to ground is plus 20 volts because we have the voltage source directly connected between this point and ground. So this branch current is V2 minus 20 over 4, and this is equal to 0. So this completes step 3, which is applying KCL to the remaining nodes. Next step is to solve these equations. I'm going to solve these equations using my scientific calculator. Using the solve command on my calculator, I can directly enter the node voltage equations with variables V1 and V2, and the solution using the calculator is shown here. So using the calculator, we can show that V1 is equal to 144 by 5, which is 28.8 volts, and the second node voltage is 84 by 5, which is 16.8 volts. So this completes step 4, solving the equations. The final step is to solve for the circuit variables, and in this case we are required to find the power associated with the voltage sources. So let's see how this is done. Suppose we assume this is the current direction for the 40 volt source. So let me denote that as Ix. And suppose this is the direction of the current for the 20 volt source, which is Iy. Now, the power associated with the 40 volt source, so power is the voltage, which is the magnitude 40, and then the current, which is Ix. We need to apply passive sign convention to decide the sign. So here the current is entering the terminal marked negative, so we write the power calculation with a minus sign. The next step is to just substitute and get the values. So this is minus 40, and this current Ix will be voltage at this side minus V1 over 2. So this will be 40 minus 28.8 over 2, and this is equal to minus 40 multiplied by 5.6, and this is minus 224 watt. So the final answer is negative, and this signifies that this voltage source is generating power. Similarly, for the 20 volt source, the power is given by the product of the voltage and the current. So this will be 20 multiplied by Iy. And looking at this current direction, this is entering the terminal marked minus. So applying passive sign convention, we write the power with a negative sign, and then we just substitute values. So this is equal to minus 20, and Iy will be 20 minus V2 over 4. So this is 20 minus 16.8 over 4, and this is equal to minus 20 times 0.8, which is minus 16 watt. So the final answer is negative, which signifies that this voltage source is also generating power in this circuit. Finally, we can verify our solution for the node voltages using PSPICE. So this is the simulation result obtained by simulating the circuit in PSPICE, and we can see that the node voltages are exactly as we calculated.